Hey folks, welcome back. It's me again, Mr. Tuttle, here to talk about page 2 of the guided notes for section 10.4. The last page of these notes is just a bunch of examples where the examples get kind of more and more complicated as we kind of move forward with adding and subtracting these radical expressions. So I've got as much as I can fit on the board here, starting with example number 2, the two examples of number 2. So let's get into it. Here we go. So, first thing I'm looking for if I'm adding and subtracting, do I have like radicals? And if I look here, 3, 3, 3 for the index, and the radicand for each of those is AB. So we're good to go. We can start adding them together. I'm going to look at those kind of like coefficients out in front. For this one I've got -2. Second one I've got +7. And then, of course, low-key, in the last one I've got a -1. Okay. Put those boys in parentheses, and that's what we're adding. We're adding square roots of AB. And then I just simplify what's inside those parentheses, and I'm done, right? -2 plus 7 is +5. +5 minus 1 is 4. So the final answer here, 4 times the square root of A times B. Cool. All right, the next one, same thing. What do you do first? You check to see if you got like radicals, and you do. Both are square roots, and both have a radicand of 3y. We do have these fractions, but I'm cool with fractions. We're cool with fractions. Everything works the same. This is 1/4 x as a coefficient. This is -3/2 x, and I'm adding square roots of 3 times y. All right, I'm going to do some stuff with fractions kind of behind the scenes. I need common denominators. This is going to become 6/4, right? Actually, maybe I'll just do this. It's going to be 1/4 x minus 6/4 x times the square root of 3y. And now I can do my thing here. 1/4 minus 6/4 is -5/4 x times the square root of 3y. That's a wrap. Okay. So we're on to example 3. There's really, I mean, we're doing all the same stuff. Nothing different in these examples except, like I said, they're going to get a little more complicated or interesting depending on your frame of mind. I like to think that they're just more interesting. Let's do this. 3 times the square root of 8 plus the square root of 2. Not like radicals. So we just move on and skip it. Or, what if we simplified this? This is 3 times the square root of 4 times the square root of 2. And that's just the square root of 2. Square root of 4 is just 2. So now I've got 3 times 2 times the square root of 2 plus the square root of 2. 3 times 2 is 6. There's a low-key 1 in front of that other one. So my final answer looks like 7 times the square root of 2. So, yeah, don't just give up if you see that they're not like radicals. See if they can be simplified, and if they can, do that. And then if you end up with like radicals, you can keep going, and then, you know, you're good to go. All right, the next one, and then I'm going to have to take a short break and make some more space on my board. Again, not like radicals, but I'm going to try to simplify. I'm going to break this down into 8 times the square root of x squared times the square root of x times the square root of y squared minus 3y times the square root of x squared times the square root of x. Poof, it's a lot. I'm doing a lot. But now I can simplify. I'm probably gonna squeeze a few steps at the same time into one just because I don't have the room here. What's the square root of x squared? Everybody say it. It's x. What's the square root of y squared? Everybody say it. Yup, it's y. What's the square root of x squared? Yes, yes, it is x. So I'm going to have 8xy and the only thing that got left behind that could not be simplified was that x square root of x, right? Here, this is just going to be 3xy. Oh, negative 3xy, right? With the square root of x. So this is going to be negative 3xy. Ooh, can't believe I fit it in there. Yeah. So, there we go. Now we've got like radicals. 8xy minus 3xy, you said it. 5xy times the square root of x. Nice. Okay. I'm going to start moving quickly because I want to keep this video under 10 minutes. Let me know if you have any questions. No? No one's got questions? Awesome. It must mean I'm doing a great job. If you do have questions, hit me up on office hours, folks. Otherwise, I'll just be taking a nap instead of teaching. Much rather be teaching. Anyway, onward. Here we go. 50 times the square root. Oh, I already messed up. Square root of 50, x squared, y to the 5th, minus 13y times the square root 2x squared, y to the 3rd, plus xy times the square root of 98, y to the 3rd. I'm already regretting putting this one on here. Whew, this is a lot. Clearly we don't have like radicals, but clearly we can simplify them. So let's do that. Take it one piece at a time. These are all square roots, so I'm trying to get perfect square factors out of each of these terms, out of each of these factors, starting with the square root of 25 times the square root of 2, the square root of x squared. That is a perfect square, but what am I going to do with this y to the 5th? I'm going to pull out a y to the 4th and a y. Okay? All of these come from this first term. Okay? I'm going to do the second one down here. I've got negative 13y, or yeah, negative 13y. That's just the square root of 2. Square root of x squared is already a perfect square. Square root of y squared and square root of y. These 4 terms is what comes out of, yes, those 4 terms is what comes out of that radical. And then here, you've got xy times the square root of 49 times the square root of 2 times the square root of y squared times the square root of y. Right? Hopefully you have enough space for all of this in your, I try to give you lots of space in the sheet. Feel free to use a blank sheet of paper if you're running out of room. But everything's broken down. Now I just need to take the square roots, put everything back together. This is going to be 5x y squared. Square root of this is 5, square root of this is x, square root of this is y squared. What's left? Square root of 2, square root of y. I can put them under the same radical since they both have the same index. That's the first, that's this. Here, negative 13y, x, y. So what I'm going to end up with is negative 13y squared and then an x. So I've got negative 13xy squared, which is cool because these are like terms. I'm going to be able to combine these at the end. What's left over is square root of 2y. Again, also cool because those are like terms, like radicals. Okay, Last one, 7y times xy is 7xy squared. Square root of 2, square root of y were left over. So boom. Now I'm ready to finish this up. This minus this plus this. 5xy squared minus 13xy squared plus 7xy squared times the square root of 2y. My gosh, we're so close. 5 plus 7 is 12. Minus 13 is negative 1, or just negative xy squared times the square root of 2y. Man, it's doing the most. That's what we do. Okay? Last one. Last one actually goes pretty quickly. I can just do the last one under here. Okay? It says 3 times the square root of 2x squared plus the square root of 8. Cool. We know what to do. Simplify, simplify. This is going to be 3 times the square root of 2 times the square root of x squared plus the square root of 4 times the square root of 2. This becomes 3x times the square root of 2. This becomes 2 times the square root of 2. Like radicals, we're good. But these 3x plus 2, which are the coefficients in front, they are not like terms. So when that's supposed to be a parentheses, I can basically factor out the square root of 2, and I can put my answer like this. That's legit. Low key, honestly, if you keep it like this, I won't even be mad at you. But just know, when you end up in this situation, if those are not like terms, you can factor them out and your answer could look like this. Good to know. See you later.